Hi students, in this lecture we are going to learn the modulus or amplitude form of a complex number. Modulus amplitude form of a complex number. In the previous lecture we discussed amplitude of a complex number or how to find out the argument of a complex number. Now consider a complex number z equals to x plus iy. Okay, I am representing in orgone plane. So where the horizontal axis is taken as real part of the complex number and the vertical axis is as imaginary part of the complex number. Considering complex number in the point form as p of x comma y. Okay, so now from the origin, consider the radius vector to the point P. Okay, generally, which is nothing but distance between the origin to the complex number, where which can be written as modulus of a complex number, which is equals to square root of x square plus y square. Okay, square root of x square plus y square, where which is nothing but the modulus. In general, we are representing with r. Okay, so we can represent this is as r. R is equals to square root of x square plus y square. Now draw a perpendicular to the real axis, that means real part of the complex number. From the point P, draw a perpendicular line. Okay, let I consider this is as point A. So OA is what it is, the x quadrant, which is nothing but the distance OA is simply x and AP as y. Okay, now what is the argument or amplitude? Amplitude is an angle, so which is to be considered from the real axis. Okay, real axis, positive real axis to radius vector. So now which is the theta, where theta is the argument. So now here the r is modulus and theta is argument or amplitude. Okay, amplitude of the given complex number. Now we can represent, considering sine theta, what we'll get over here from this one, I am writing it as sine theta equals to, so what is the sine theta? Opposite by hypotenuse, which is r. So from this one we can write it as y equals to r sine theta. Okay, so next apply cos theta over here. Cos theta equals to, so adjacent by hypotenuse, x by r. So we can write it as x is equals to r cos theta. Okay, now we are representing the y, which is nothing but the imaginary part of the complex number. Y equals to r sine theta, where r is the modulus, theta is the amplitude, and x is equals to r cos theta. So what is x? X is the real part of the complex number. So I can write it as y as imaginary part of the complex number, x as real part of the complex number. Now I can represent z equals to x plus iy. I am replacing x with r cos theta and y with r sin theta. So I can write it as r cos theta plus I times of, where y is nothing but r sin theta. Okay, so from this one we can write it as complex number z equals to r times of cos theta plus I sin theta. Okay, complex number z is equals to r times of cos theta plus I sin theta. So now where r is equals to, I am writing again, z is equals to r cos theta plus I times of sin theta. Okay, given complex number is x plus iy which is also be represented as r cos theta plus r times of cos theta plus I sin theta, where r is the modulus of the complex number and theta is the amplitude of the complex number. So in previous lectures we learned how to find out the modulus of a complex number and how to find out the amplitude of a complex number. Please watch the videos to know about the modulus of a complex number and amplitude of a complex number, where r can be written as square root of x square plus y square. Okay, now complex number which is in the form z equals to r times of cos theta plus I sin theta is called as, okay, where theta, what is theta, must be belongs to the principal amplitude, what is minus pi to plus pi, okay, where theta must belongs to the principal amplitude minus pi to plus pi. Why? Because theta is the amplitude and it must have the unique value. That unique value is defined from minus pi to plus pi. Any complex number is in the form of z is equals to r times of cos theta plus I sin theta is called as modulus amplitude form of given complex number z equals to x plus iy, or z of x plus z equals to x comma y, okay, which is the modulus amplitude form. Okay, if the radius equals to 1, I am considering if the radius, that means radius means the modulus equals to 1. Okay, if the modulus equals to 1, then the complex number will become z equals to cos theta plus I times of sin theta. Okay, cos theta plus I times of sin theta. So which is in general represented as cis theta, which is in general represented as cis theta. Okay, we discuss few things about this cis theta. Okay, so cis theta equals to cos theta plus I sin theta. If cis of minus theta, what will become it is? So cis theta equals to cos theta plus I times of sin theta. Then what is cis of minus theta? Then what will get here cis of minus theta? Cos of minus theta plus I times of sin of minus theta. So cos of minus theta equals to cos theta plus sin of minus theta equals to minus sin theta. So we can write as minus sin theta. Okay, so we can write as cis of minus theta equals to what it is, cos theta minus I sin theta. Okay, next consider the two complex numbers where z1 equals to, okay, z1 equals to r1 times of cos theta 1 plus I sin theta 1, and another complex number z2 equals to r2 times of cos theta 2 plus I sin theta 2. Okay, now what is the resultant? z1 into z2. Okay, multiplication of two complex numbers results another complex number. Now I am performing over here directly multiplying r1, z1 and z2. We will get over here as r1 into r2 times of cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. So by doing multiplication, we will get the result as this is the one, and I am directly writing it as r1 into r2. Separate the real and imaginary parts. What we will get cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, which is as real part, plus imaginary part. Okay, sin theta 1 cos theta 2 plus cos theta 1 into sin theta 2. Okay, which is in the form of cos A cos B minus sin A sin B, which is nothing but cos of A plus B, which is equals to cos of theta 1 plus theta 2 plus sin A cos B plus cos A sin B, sin of A plus B, which is the resultant as sin of theta 1 plus theta 2. Okay, so from this one we can write it as z1 z2 is the resultant as cos of theta 1 plus theta 2 I sin of theta 1 plus theta 2. So if r1 equals to 1 and r2 equals to 1, then we will get, if r1 equals to the radius as 1, what is modulus of the complex number 1 as 1 and the modulus of the complex number 2 also 1, then we will get z1 into z2 equals to cos of theta 1 plus theta 2 plus I times of sine of theta 1 plus theta 2. Okay, and just we discussed that if any complex number z is equals to cos theta plus I sin theta, we can write it as cis theta, and we can write these two as cis of theta 1 plus theta 2. Okay, what is cis theta? Cos theta plus I sin theta, and cis of theta 1 plus theta 2 is cos theta 1 plus I sin of theta 1 plus theta 2, which is the z1 and z2, which is the multiplication of two complex numbers in the modulus amplitude form. Okay, modulus amplitude form, and the modulus amplitude form is also be called as polar form. Okay, modulus amplitude form is also be called as polar form. Okay, so now we considered z1 equals to cos theta 1 plus, okay, we considered z1 equals to, and considering r1 equals to 1, then we are getting it as cos theta 1 plus I times of sin theta 1, and z2 equals to cos theta 2 plus I times of sin theta 2. Okay, then what is the argument of this complex number? Simply nothing but argument of z or amplitude of z can be written as, okay, amplitude of z can be written as tan inverse of imaginary, what is the imaginary, sin theta 1 by real part cos theta 1, and what we'll get over here, tan inverse of tan of theta 1. Okay, where theta 1 is the argument of the z, then we can write it as argument of z1. Okay, sorry, here it is z1, argument of z1 is theta 1. Okay, is it clear? Okay, right. Now what is the argument of z2? Simply we can write this is as argument of z2 equals to tan inverse of imaginary, sorry, tan inverse of imaginary sin theta 2 by real part cos theta 2, and we will get this is as tan inverse of tan theta 2, and theta 2 is the argument of complex number z2. Okay, argument of complex number z2. Okay, and we obtained when we product these two z1 into z2, and what we'll get over here, cos of theta 1 plus theta 2 plus I times of sine of theta 1 plus theta 2. Okay, then if we find the argument of z1 z2, the product here, the argument of z1 z2 is nothing but tan inverse of imaginary sine of theta 1 plus theta 2 by cos of real part cos of theta 1 plus theta 2, which is equals to tan inverse of tan of theta 1 plus theta 2. Okay, which is the resultant equals to, simply we can write as theta 1 plus theta 2. Okay, what we are getting over here, argument of z1 into z2. Okay, now we can write over here it is as argument of z1 into z2 is equals to, what is theta 1 we obtained over here is theta 1 as argument of z1, argument of z1 plus theta 2 is argument of z2, which is the important property related to the arguments. Okay, argument of the product of the complex numbers is nothing but sum of the individual arguments of the complex numbers. Okay, argument of z1 z2. And what we discussed here, one thing we discussed is what it is, cis theta 1 into cis theta 2, which is nothing but z1 into z2 is nothing but cis theta 1 into cis theta 2 is nothing but cis of theta 1 plus theta 2. Okay, which is the another important property. Okay, we need to consider these 2 points. Okay, in the relation to the product of the complex numbers z1 z2. So the product of the 2 complex numbers results to the, simply the resultant amplitude is added, the argument is added, cis theta 1 into cis theta 2 equals to cis of theta 1 plus theta 2, and argument of, okay, argument of z1 into z2 can be written as argument of z1 plus argument of z2. Okay, now consider, again I am considering z1 equals to r1 times of cos theta 1 plus I times of sine theta 1, and z2 equals to r2 times of cos theta 2 plus I times of sine theta 2. What happens if it is z1 by z2? Simply we can write as z1 equals to cis theta 1 and z2 equals to r2 into cis theta 2. Okay, is it clear? So if r1 and r2 equals to 1, then z1 equals to cis theta 1 and z2 equals to cis theta 2. Then what it is, z1 by z2, okay, which is equals to r1 times of cos theta 1 plus I sin theta 1 by r2 times of cos theta 2 plus I times of sin theta 2. Okay, where r1 and r2 are the numbers, then r1 by r2 we can write it as, then what it is, if two numbers are complex numbers are divided, then simply rationalize with the denominator conjugate. Okay, simply rationalize with the denominator conjugate. So what is the denominator? Cos theta 2 plus I sin theta 2. Then we need to multiply, rationalize with cost, multiply with cos theta 2 minus I sin theta 2 by cos theta 2 minus I sin theta 2. Okay, if we do simplification for this one, r1 by r2, simplify, you will get, this is the resultant, and So over here r1 by r2 times of, and separate the real and imaginary parts, cos theta 1. So by simplifying we'll get the denominator as 1. Then if we simplify further, what we'll get, r1 by r2 as cos theta 1 cos theta 2 plus sin theta 1 sin theta 2, which is nothing but cos of theta 1 minus theta 2 plus I times of sin theta 1 cos theta 2 minus cos theta 1 sin theta 2, which can be written as sin of theta 1 minus theta 2. Okay, sin of theta 1 minus theta 2. So we can write this as z1 by z2, which is nothing but cis theta 1 by cis theta 2. Okay, r1 cis theta 1 by r2 cis theta 2. If r1 equals to 1 and r2 equals to 1, then what we'll get over here, z1 by z2 equals to cos of theta 1 minus theta 2 plus I sin of theta 1 minus theta 2. Okay, minus theta 2. So where z1 is nothing but cis theta 1 by cis theta 2 is equals to, we can write as cos theta plus I sin theta is cis of theta 1 minus theta 2. So which is the another important condition we obtain over here. Now apply the argument for this one. Then what we get, argument over here, z1 equals to, we are getting, considering it is as cos theta 1 plus I times of sin theta 1. Okay, if we consider the argument of z1, simply directly we will get it as theta 1, and we are considering z2 equals to cos theta 2 plus I times of sin theta 2. Then what will get, argument of z2 equals to, simply it is as theta 2 is the argument, theta 1 is the argument of first complex number z1 and theta 2 is the argument of complex number z2. Then what is the argument of z1 by z2? What is the argument of z1 by z2? Okay, to find out the argument of z1 by z2, we obtained z1 by z2 equals to cos of theta 1 minus theta 2 plus I times of sin of theta 1 minus theta 2. Then what is the argument over here? Argument of a complex number, here z1 by z2, argument of z1 by z2 equals to tan inverse of imaginary sin of theta 1 minus theta 2 by cos of theta 1 minus theta 2, which is equals to tan inverse of tan of theta 1 minus theta 2, which is equals to theta 1 minus theta 2, which is equals to argument of z1 by z2. And finally we can write it as argument of z1 by z2 equals to theta 1. What is theta 1? Argument of z1. Then argument of z1 minus argument of z2. Okay, so which is the another important property. Now I am summarizing all these things what we learned over here. So what we learned over here, the first thing is cis theta 1 z1 into z2, cis theta 1 into cis theta 2 equals to cis of theta 1 plus theta 2. And the next thing, cis of, so that means cis theta 1 by cis theta 2, which is equals to cis of theta 1 minus theta 2, applying the argument. Then argument of z1 into z2 can be written as argument of z1 plus argument of z2. Next, argument of z1 by z2 equals to argument of z1 minus argument of z2. Okay, these are the properties we learned in this lecture. Okay, here the argument property just like as an logarithmic property, log of ab log a plus log b, log of a by b log a minus log b. Similarly, argument of z1 z2 arg z1 plus arg z2, arg of z1 by z2 is equal to arg z1 minus arg z2. In next lecture we will do few problems on this modulus amplitude form or polar form. Okay, modulus amplitude form or polar form. Thank you.